So in order to start this, we first have to do what? All possible rational zeros, right? So you're going to do plus or minus 1, plus or minus 3, all over 1, which is just that, right? So there's only 4. There's no reason why you couldn't just do this with your regular calculator, little baby calculator, right? So we're not going to graph this. This would not be on the graphing test if I gave you one this easy. Okay, so you plug 1 in, 1 doesn't work. If I plug negative 1 in, negative 1 gives me a 0. So negative 1 is a 0. This is a cubic. How many zeros do I have to find? Just 1. Because when I do my synthetic division, what degree would I have then? A quadratic, which is what we want to get to. Okay? So we've got negative 1 in the box. And again, since I know that that is a 0, I should be getting a 0 as a remainder. That's the way you can kind of double check if you did it right. And then my quotient is a quadratic. I can deal with quadratics. I can either factor them, or if they can't be factored, I can use the quadratic formula. So this one can't be factored. So to get my remaining 2 zeros, I'm going to do the quadratic formula. Now, is there any way I can just look at this function and know whether the real zeros or they're imaginary? Nope, so you just got to plug it in. Underneath, we have 64 minus 12 is 52. Now, how do you reduce the radical? You want to think of a perfect square that divides into 52. That's
4.
4 goes into 52. So 52 is actually 4 times 13. So what is the square root of 4? 2. So that can come out. The square root of 13 can't be reduced any further. That's how you're going to reduce radicals. And then we can divide everything by 2. So those are our 2 irrational roots, and we still have that negative 1 that we started with. So you're done. Notice not a calculator was used. We can do it with that. Now, if it was a big one and there was a list of 12 rational roots that you had to try, I could see why you were getting that starting point. But with something with just 4 of them, there's no need to do that. Okay? All right. Today we're going to add a lot of the same stuff, but we're going to add complex zeros. So it all ties together. So now we're going into imaginary. We've only dealt with the real. Now we're going to add the imaginary. Okay, you have a math Excel. By the way, we're going to go ahead and do a math Excel day tomorrow. And we're going to do 3, 6 all in one day on Friday. On Friday, you're going to be given your take-home quiz, so you have all weekend to work on it. On Monday, we'll have a day in here that you can work on it, finish it up, and compare answers with your friends and discuss it. And then it's due when you walk it on Tuesday. Okay? All right. Fundamental theorem of algebra. Please do not write this whole thing down. You don't need to have this memorized. Well, you should know it, but you don't have to regurgitate it. Basically, if the degree, for instance, is 5, you have 5 zeros between real and imaginary. The one we looked at a couple days ago, we said you would have at most 5. Well, now we're saying there's exactly 5. Because if you count the real and the imaginary together, it's going to be 5. All right? Same with the linear factorization. If I have something completely factored, the linear factors, and if I have a degree of 5, I'm going to have 5 factors. I have 5 zeros, I have 5 factors. That's all that means. Whatever the degree is, that's how many zeros you have, and that's how many linear factors you have. Counting all multiplicities and all that fun stuff. Okay? Not the big thing. You just want to be able to know I have all the zeros written down. So, we have a degree 4. They gave me 4 zeros. They said x equals -2. So what is that as a factor? X plus 2. They told me x equals 1. So what is that as a factor? X minus 1. They told me x equals I. So what is that as a factor? So it's the same stuff that we've been doing. There's nothing really new here in this first step. So how many factors do we have? 4. They're going to match the number of zeros you have. That's what that linear factorization thing says. And then they said we have a leading coefficient of 3. So these are all my factors. I didn't want to do that, but okay, there's all my factors. And my leading coefficient is a 3. So that's my polynomial that they want me to write. Okay. In factored form. Then they want you to put it in standard form. And this is where the lesson is kind of a pain in the butt because we're going to be multiplying a lot today. Okay. So we should we should FOIL what together first? These guys with the eyes, those are conjugates. So when I FOIL these, I get x squared. The outside and the inside, because this is a binomial, the outside and inside are going to cancel. I'm going to go ahead and write it out, but they always cancel with a binomial, the O and the I. Okay, so these guys are gone. What does I squared equal? 1. So negative 1, it equals a -1, changes to a positive 1. So this guy can FOIL together to give you x squared plus 1. These two guys I'm going to FOIL together. I get x squared, negative x plus 2x is plus 1x, and then minus 2. Okay. And then we still have the 3. We're not done. You've got to FOIL that together. But we're no longer FOILing because it's a 3 by 2. It doesn't matter which you multiply first. I'm going to go ahead and multiply the big factors first. So x squared times x squared is x to the 4th plus x squared plus x cubed plus x minus 2x squared minus 2. This is 3 terms. This is 2 terms. You should have 6 before you simplify. And all you're doing there is you're taking this x squared to both, the x to both, the -2 to both. Okay? So the x squared and the -2x squared is going to go together to give me a -x squared. Okay? We're still multiplying by 3. So I have an x to the 4th, so that's going to be my first term. My x cubed is going to be next. My x squared is at the back. I'm still going to put that following. Cube, my regular x. And then the -2 gets the 3. Okay? That is in standard form, and I know it takes a minute to do. I get it. But notice, we wrote the zeros, we wrote the factors, we can multiply. There's nothing that you can't do. Just like with irrational zeros. If you have an irrational zero, its conjugate also is a 0. Same with the complex imaginary. So a plus bi is a 0, a minus bi is a 0. Okay? So that's the conjugate's theorem. You need to know that. That's huge. Alright? Conjugate zeros. Alright. Let's see what that gives us. We want to write a polynomial with real coefficients having the degree 6, leading coefficient of negative 2. The zeros are 2 minus 5i and negative 3 plus 2i, and 2 with a multiplicity of 2. They want to write it as a product of linear and irreducible quadratic factors. So let's start. If I have the x equals 2 minus 5i, and they told me x equals negative 3 plus 2i, and they told me x equals 2 with a multiplicity of 2. What else do I know? Because they told me I have a degree 6, and I just see 4 there. I've only got 4. I need 2 more zeros. So if 2 minus 5i is a 0, what else is a 0? So you have to write those conjugates down. They're not going to give them to you. So now I have 1, 2, 3, 4, 5, 6, because I have a multiplicity of 2 there. So I have all my zeros written. And then we're going to write our factors. Don't worry that you have 2 numbers. You're just going to move 2 numbers over. So it's going to be x minus 2 plus 5i. X minus 2 minus 5i. So even in the factors, the imaginary part is the only thing that should be different. X plus 3 minus 2i. X plus 3 plus 2i. And then the real factor, or real zero, is going to be x minus 2. It has a multiplicity of 2, so we're going to square the factor, if you remember. Right now, we have linear factors. Linear factors have an x to the first power. They want linear factors and irreducible quadratic factors. So we can't, I misspoke here. This is not linear because it has an I in it. You've got to multiply the conjugates together to get rid of the i's. Then it would become a quadratic factor that's irreducible. Okay? So let's multiply it out. So this guy here, and it's a 3 by 3, so big long string of numbers here. You're going to have x squared minus 2x minus 5xi. Down with the x, taking the negative 2. Done with the negative 2. Now I'm multiplying by the 5i. So this is not a quick thing to do. It's going to take you some paper and pencil. So if it is imaginary, at this point it should cancel. Remember, I squared is negative I, so it's going to change this to a positive 25. So as an irreducible quadratic factor, we're going to have x squared minus 4x plus 29. There is no quick, easy way to do that. Okay? We're going to do this guy next. Same thing, it's a 3 by 3. So it's going to take 9 little multiplications. And again, all the imaginary pieces should cancel. And you would have x squared plus 6x plus 13 when you gather your like terms. And don't forget your x minus 2 linear factor that is squared for the multiplicity. Now go back up to what they asked you to write. Make sure you have everything we need. We have a degree 6. If I add these exponents, I have 2 from this factor, 2 from this factor, 2 because of the multiplicity there. Degree 6. Leading coefficient of negative 2. We do not have that, so we're going to write it out front here. And we have irreducible quadratic factors and a linear factor. Okay? Does that make sense? It takes a minute. So find the equation of a polynomial function of the least degree having the given complex zeros, intercepts, and graph. F has complex zeros I and 2 i's. So they told me x equals I. What else do I know? X equals, what's the conjugate of this guy? Negative I. They also told me 2i, so we also have to write down that conjugate, which is negative 2i. So those are the complex roots. We see a root on the graph. What's the x-intercept? X equals 3, right? Okay. So we've got, appears to be a 5th degree. Does that match with an in behavior of up and down? Is that an odd in behavior? So far, so good. So this is not crossing at 0. That's a y-intercept of 4. Okay. Here we go. We're going to write the factors. So we've got x minus 3, x minus I, x plus I, x minus 2i, x plus 2i. We have to multiply the conjugate factors together at least. They didn't tell us to put it in standard form. But if it's not in standard form, then it should be in irreducible quadratic linear factor form. Okay. So, but this is nice. These are 2 by 2s. These are binomials. So I just have to FOIL the f and the l. So this is going to be x squared minus I squared. What does that equal? X squared plus 1. And over here we have x squared minus 4i squared. So as a factor, that's x squared plus 4. And then we would have our x minus 3. Okay? So again, let's go back up to see if we have everything we need. We have all the zeros they gave us. They told us, they gave us a graph. What else did they give us on the graph? The y-intercept. The y-intercept on the graph is 4. What's the y-intercept currently on our graph, our equation? If my x's were zeros, the first guy would have negative 3 times 1 times 4. What does that equal? Negative 12. It needs to be a positive 4. What would I have to multiply a negative 12 by to get a positive 4? Negative what? I have negative 12. What do I have to divide by? You have to divide by negative 3, right? So our leading coefficient is negative 1/3. Okay? So you can do that without foiling it out. Or you could foil it out and see, my y-intercept is negative 12. I need to be a negative. Or a positive, I'm sorry, 4. Okay? You got to be able to find the y-intercept if you're going to do it that way. That's going to bother me, that's all. All right. Here we go. Given 2i is a 0, find the remaining zeros. Well, I know 1 right away. If x equals 2i is a 0, I automatically know x equals negative 2i. I am already getting a point on this problem, even if I don't know anything else. I want to put those in factors. Now, if these were irrational roots, or rational roots, I'd be doing synthetic division and finding things. I can't do synthetic division with an imaginary k value. So, we're going to FOIL this out. X squared minus 4i squared. So I have x squared plus 4 as a factor. We have to divide with it, just like we were before. But we can't do synthetic division because it's an x squared. So if you've been asking yourself, when are we going to get to use long division? The answer is now. I know you were waiting. Okay, so long division. X squared, make sure you put a 0x there for a placeholder. Divided into okay. And then you're going to do your long division. And just kind of go through your steps. What's my remainder going to be? What should it be? I'm dividing by a factor. 0. If it's not 0, that's telling you you did something wrong, either with your FOILing or your long division. Okay. So now I have a nice quadratic as a quotient. At first, I'm going to look at and say, can I factor it? Can I factor this? Factors of 2 that add to negative 3 are negative 2 and negative 1. So the zeros I get from those factors are 2 and 1. And then the original 0 I was given in the conjugate is plus or minus 2i. This is a 4th degree, so I should have 4 zeros between imaginary and real. That makes sense? That's what we're going to be doing. So, next example. You guys try it. So, do you have your 2 conjugate zeros? Do you have them written in factors right? Did you FOIL it out right? Now, what do we have to do? Divide. Do long division, yes? Do your long division. Go for it. Again, we're looking for that 0 remainder. So you should get x cubed plus x squared minus 2x for the quotient. So we're going to bring that up here, and we're going to say, can I factor this? You can see I can take an x out, yes? Are there factors of 2 that subtract to 1? Yes, they would be 2 and negative 1. So my zeros are 0, negative 2, 1, and 3 plus or minus I. Right? And we count 1, 2, 3, 4, 5 zeros. It's a degree 5. You should always check that because a lot of times you forget about this poor little x out here. He creates a 0, 0. So if you count your answers and you go, okay, I have a degree 5, that's why they have that fundamental theorem of algebra, so you can double check that. You should have 5 answers. You get the gist of what we're doing? How's the spelling today? 47? Let's just talk about the next one, shall we? I'll do it quickly. You guys can just watch. Okay, find all real zeros of that quartic. They're giving you no starting point. So if you don't have a starting point, you have to find your own, right? So we're not just going to graph. We're going to find the possible rational roots. So this would be one that I'd say, you know what? Let's go ahead and graph and find a starting point. How many starting points do you need? I have a quartic. I have to drop it down to a quadratic. So I need to find 2 rational zeros. Benny, are you graphing it for us? I'm trying to remember. Is it 2 and 4?
Yeah.
2 and 4, okay? So we can graph those and see it crosses nice and pretty at 2 and 4. So I would do the synthetic division. It does not matter which 0 you start with. You're going to end up at the same spot. But remember, you're going to use your answer from the first as your new coefficients. And you're left with this quadratic. Don't go crazy yet, guys. Can I factor x squared minus 2x plus 2? No, so I have to do the quadratic formula. Gosh, there's a lot of 2's there. Negative 4. What is the square root of negative 4? Square root of negative 4. 2i. The negative just comes out as an I. And you simplify the square root just like you normally would. All of those divide by 2. So you get I, or 1 plus or minus I, and then you have the original 4 and 2. So I have a 4th degree, I have 4 answers. Okay? Everyone understand? So, tomorrow, we will probably do maybe one or two of these as a warm-up. We got through most of everything. And then bring your Chromebooks, because you don't have time to do Math Excel.